Okay, 5.2, this is on verifying trig identities. This is when we take one of our identities where we say one trig function is equal to some variation of our other trig functions. We want to verify these things, and there are a lot of ways to do this. You can kind of demonstrate it by plugging in some value. Like I could say, I could plug in 45 degrees and prove that the sine of 45 degrees all squared is equal to a 1 minus the cosine of 45 degrees all squared. But that doesn't really prove it. That doesn't verify it. That demonstrates that it works in one case. Okay. So in order to prove it, what we do is we take our equation and we pick one of the sides and rewrite it so that it equals the other side. We manipulate it, we apply our various identities to it, various algebraic operations. We can also work with both sides. I can make my left side kind of look like the right, and if I get stuck, I can work on the right side for a while. But really, the one thing you got to keep in mind is that this is very different from solving an equation. We can't do something to both sides at once. Like I can't say I'm going to add 5 to both sides. I'm going to subtract out sine from both sides. You have to work with each side separately. By applying identities to just one side. And while you can work on the other side as well, you can't do anything to both sides at once. So well, I'm trying to think of a good example where you would do it. If I see one, I think we may have one example in this problem we're going to do in a second. We'll look at a potential pitfall where you could make that mistake. Okay. So some of the tips for doing this, learn your fundamental identities. So when you see one side or either side of these, the other side should immediately come into mind. And this is a great example that they give you. When you see sine squared, you should recognize that that could be rewritten using our Pythagorean identity as 1 minus cosine squared. Okay. Similarly, if I see something like 1 minus sine squared, I know I can rewrite that as cosine squared. So if I see, so I'm going back to my list here. If I see cosine over sine somewhere, if you see cosine over sine, you should immediately recognize how I could rewrite that as tangent or cotangent. Typically, we're using that, which is more important with the Pythagorean identities. Like if you see you've got 1 minus secant squared, that equals negative tangent squared. If you're having trouble, take these and solve them for each one of the variables. Like we've done that for sine squared and cosine squared for the Pythagorean identities. For the first one, you could do the same thing for these other two. Right? You could also multiply this through by -1, and you should still be able to recognize it. So that's the first step, particularly with these Pythagorean identities. You should be able to recognize them in any way, shape, or form. Step 2, or tip 2, try to rewrite the more complicated side. In general, it's easier to take a complicated expression and simplify it than it is to take a simple expression and try to make it more complicated. So that's it may seem obvious, but you want to work with a complicated side and make it look simpler rather than the other way around. My favorite rule, rewrite everything in terms of sine and cosine if you get stuck. Step 4, factoring. I didn't include any problems that involve factoring per se. We're actually going to do a few of these that involve, let's see, which one of these rules? This one right here, a squared minus b squared equals a plus b a minus b. That's actually a really important one. Shapes. Okay. What we're going to do something called multiplying by the conjugate, and it's going to allow us to write something that looks like this on the right as something that looks like this on the left. And we'll talk about that. We've got two examples that involve that. We won't be factoring, but we will be going the other way. Okay, we didn't do a lot of fractions either. Step 5, always a good one. Keep in mind, or tip 5, keep in mind the side that you're not working with, because that tells you where you're going, you know. So look at, make sure you're heading in that direction. If it looks, so for example, this one, we're trying to write this in terms of cosine squared. That tells me we should be moving towards cosine, not towards some other trig function. We actually kind of did this one earlier. We want to use secant to relate tangent to cosine, rather than use one of our other identities. So keep, look at both sides. Make sure you're heading in the right direction, not just going off on some wild tangent. And finally, this is what we're going to talk about the majority today, because it's something that's covered a lot in algebra courses, but it's not something that makes a lot of sense in algebra courses. I know a lot of students ask me why we cover that stuff. It's very useful in trig, and it's not the most intuitive thing, so I really wanted to go over this. So if you've got two terms in your denominator like this, say 1 plus sine of x in your denominator, if I multiply by 1 minus sine of x, that's going to give me 1 minus sine squared, which is one of our Pythagorean identities. So that comes from this rule. If I've got two factors, a plus b and a minus b, where the only difference is the sign in between them, plus and minus, then I can write that as the first term squared minus the second term squared. Okay. So look at what we're talking about here in part 6. 1 plus sine of x. I multiply that by 1 minus sine of x. So the only difference there is one is plus and one is minus. So what do? We square the first term. So we're going to square 1. All right, 1 squared is 1. And then we square the second term. So we get sine squared. So that's how they got 1 plus sine of x times 1 minus sine of x is 1 minus sine squared of x. There's that. It's hard to recognize because there's no square on that 1. But that's just this rule right here. 1 squared is 1. Okay. So that one, it comes up a decent amount in trig, and it's simplifying trig expressions, and it only makes sense if you've seen it before. So that's what we're focusing on. Okay, so we've got, okay, good. So I do have this conjugate rule written out. So our conjugates, that's when we have those two factors, a minus b, a plus b, that have the opposite sign there. And here's how we apply it. If I've got something like, say I've got the difference of two terms in the denominator, I multiply the top and the bottom by the same terms but with a plus sign. I'm allowed to do this, because when I multiply by a fraction where the top and the bottom are the same, that doesn't change what I started with. This is still equal to 1 over a minus b, except now I've got this denominator in this beautiful form that will simplify. And the numerator simplifies really easily too. 1 times a plus b, in our case, is just a plus b. And the denominator, our rule tells us we can square the first term, square the second term. And if you don't like the rule, you can always just FOIL this out, and you'll see the outside and the inside terms cancel, which is what allows us to do this. Okay. So now let's actually apply this. And this is example 4 from the textbook. We're trying to verify this identity. So when I see this, the very first thing that pops out to me is I've got that 1 minus sine of x and the denominator of this left side. So that immediately tells me, okay, that's something I can multiply by the conjugate, and that's going to allow me to simplify this. So right away, I know that this is a complicated, well, they're both complicated, but this is a complicated one that I know how to simplify really easily. Now over here, I've also got a conjugate. You know, I've got 1 plus sine of x. I could multiply that by the conjugate. Typically, when I've got a choice like this, I'm going to choose the one that's in the denominator. And you'll see why in a minute here. Okay. So, I've decided to work with just the left side of this. I want to multiply. I'm going to start off by multiplying by this conjugate 1 plus sine of x. Okay. So that's what I do. In the denominator, I've rewritten it with parentheses just to make it more clear. And in the denominator, I square my first term, I get 1 squared. I square my second term, I get sine squared. In the numerator, I didn't multiply that out. I could have multiplied it out, but because I know that I'm going to be able to simplify the denominator a little bit further, I'm not going to do that until I've simplified that denominator. So 1 squared minus sine squared, we're just looking at that denominator. In the next line, all I've done is rewritten that 1 squared as 1, because 1 squared is just 1. Okay, and now I've used the Pythagorean identity to write that as cosine squared, which is why it's important to recognize these Pythagorean identities in all the different forms. And this is why I didn't multiply out my cosine in the numerator, because I've got a cosine in the numerator, 2 cosines in the denominator. I can cancel one of those cosines from the denominator with that cosine from the numerator. And that's just what I do on this line here. I cross out that one in the numerator. I cross out one of those 2 in the denominator. And so I'm left with 1 plus sine of x on top and cosine on the bottom. And that's what my right side was. So when I've played with this thing and I've gotten the left side to look like the right side, I've just verified this identity is true. I took other things, other rules that I knew were true. I rewrote one side using those rules until I made that side look like the other side. And that was it. Now this may look like a lot of steps, but it was really, there's only one important step there, and that's multiplying by this conjugate. Everything else was just simplifying. Okay, so next up, this is example 5 from the textbook. This is the same idea. I've got a lot of stuff going on, but on the left side, I see I've got this complicated denominator. I immediately think, okay, I can multiply by the conjugate to get rid of that denominator. So I've got secant minus tangent in the denominator. I multiply by secant plus tangent. That allows me to square secant, square tangent, take the difference. And that is going to be one of my Pythagorean identities as well. Secant squared minus tan squared is 1. So a beautiful result there. Now what did I do in the numerator? I had these 2 factors again. I can just FOIL those out. Multiply the first 2 terms, I get secant squared. Multiply the outside term, I get secant tangent. Multiply the inside terms, I get secant tangent again. So I've got 2 of those secant tangents. And then multiply my last terms. So I get tangent times tangent is tangent squared. Okay, so that's what I did in the numerator. I FOILed out these first 2 sets of secant and tangent. Okay, and just carried that down to this line. That numerator doesn't change for those 3 lines. So now I've got this. It doesn't quite look like what I've got over here on the right, but I recognize this is only written in terms of sine and cosine, and since that's one of my favorite things to do anyway, in trig, I'm going to try to rewrite each of these as sine and cosine. I'm going to do that using my my fundamental identities there, the reciprocal identities. So secant squared is equal to 1 over cosine squared. 2 secant tangent is going to be equal to 2. I mean, the 2 I just carried down. Secant is 1 over cosine. Tangent is sine over cosine. And then finally, this tangent squared is sine squared over cosine squared. Okay, so it may not look like it, but this is a good place to be in. In this middle term, I can take my cosine times cosine and get cosine squared. 2 times 1 times sine is just 2 times sine. And now that I've got this cosine squared in the denominator of all three of my fractions, I can write that as one big fraction. 1 plus 2 sine plus sine squared. And there is my combined fraction, which equals the right side that we were shooting for. So I really like this one. It gives you practice multiplying by the conjugate. It gives you practice rewriting in terms of sine and cosine. A little bit of work, a little bit of practice combining your fraction. So great example. Definitely something you need to make sure you can get through. Your homework, I gave you a bunch of problems that involve writing in terms of sine and cosine, and some other problems that don't involve the conjugates, but those should be no problem, particularly when compared to this. I think this is probably the most difficult, so that's why I've got 2 different problems on it.